Hello students. Hello and welcome to this video on permutation and combination. We will solve 10 more problems on permutations and combinations starting from question 241 to 250. So the link to download the PDF will be in description, and at the end I'll show you how you can download other books as well. So without further ado, let's get started. Question 241 says that if n minus 2 P4 is to n plus 2 C8 is equal to 16 is to 57, find the value of n. So we are given that n minus 2 P4 is to n plus 2 C8 is equal to 16 is to 57, right? So we expand this, n minus 2 P4 becomes n minus 2 factorial divided by n minus 6 factorial, and n plus 2 C8 becomes n plus 2 factorial in the denominator and 8 factorial multiplied by n minus 6 factorial in the numerator. So this essentially becomes 8 factorial divided by n plus 2 multiplied by n plus 1 multiplied by n multiplied by n minus 1. Let me look at this properly. N minus 6 factorial will get cancelled and this will get cancelled. All right. So we have this 8 factorial divided by n plus 2 multiplied by n plus 1 multiplied by n multiplied by n minus 1 is equal to 16 is to 57. Now if you solve this equation for n, we get n is equal to 19. Question 242 says that if NPR is equal to NPR plus 1 and NCR is equal to NCR minus 1, find n and r. So we are given NPR is equal to NPR plus 1, that is n factorial by n minus r factorial is equal to n factorial by n minus r minus 1 factorial. That is n minus r is equal to 1. And from NCR is equal to NCR minus 1, we get 1 by r is equal to 1 by n minus r plus 1, that is by solving this. So n minus 2r plus 1 is equal to 0. So in this n minus, we put n minus r is equal to 1. So we get 2 minus r is equal to 0. So r is equal to 2 and then n becomes 3. Question 243 says that if NPR minus 1 is to NPR is to NPR plus 1 is equal to A is to B is to C, we have to prove that B square is equal to A into B plus C. So this is a given relationship, which implies that we take the first two, okay? We get from the first, not first two, first three, we get 1 by n minus r plus 1 is multiplied by n minus r divided by 1 by n minus r is to 1 is equal to A is to B is to C. So proportionally, if we take this value, then B square is equal to 1 minus n minus r whole square, okay? And A into B plus C would be 1 by n minus r plus 1 into n minus r multiplied by 1 by n minus r plus 1. So when you evaluate this thing under bracket, it will become n minus r plus 1, which will get cancelled, and the result will be 1 by n minus r square. It is not exactly this here. You can take a factor of k and then multiply all this by a factor of k, and b square will be A into B plus C. Question 244 says that if n plus 1 CR plus 1 is to n CR is to n minus 1 CR minus 1 is equal to 11 is to 6 is to 3, then we have to find n and r. So this is given, and we take the first two, we get n plus 1 factorial by n minus r factorial multiplied by r plus 1 factorial is to n factorial by r factorial multiplied by n minus r factorial. So from this relationship, we get n plus 1 by r plus 1 is equal to 11 by 6, that is 6n minus 11r is equal to 5. And we take the last two, we get similarly n by r is equal to 6 by 3 is equal to 2, so n is equal to 2r. So we put n is equal to 2r here, we get 12r minus 11r is equal to 5, that is r is equal to 5, and then we substitute back in this, we get n is equal to 10. Question 245 says, let's show that sigma k is equal to m to n kcr is equal to n plus 1 cr plus 1 minus mcr plus 1. So our left hand side, if we expand, it will become mcr plus m plus 1 cr plus so on till mcr. Now we add and subtract mcr plus 1. So mcr plus 1 we put in here and we subtract here. Now we know that mcr is equal to mcr plus 1 is equal to n plus 1 cr plus 1. So this will become m plus 1 cr plus 1, and that when combined in this will become m plus 2 cr plus 1. And then you go on combining, eventually you will end up with n plus 1 cr plus 1 minus mcr plus 1. Question 246 says that show that mcr plus 3 into mcr minus 1 plus 3 into mcr minus 2 plus mcr minus 3 is equal to n plus 3 cr. So we have this given relationship. We know that mcr plus mcr minus 1 is equal to n plus 1 cr plus 1. So what we do is we take this and 1 of this. Okay. So that becomes n plus 1 cr, and this becomes 2 into c mcr or minus 1. We take 1 of this third term and add it with the last term, we get n plus 1 cr minus 2. Then what we do is that we have this n plus 1 cr, and then we have plus 2 into c n plus 1 cr minus 1. So we add this with this, okay, and then we have that, and then plus c n plus 1 r minus 2 is here. Sorry, let me explain this a bit better. So this comes as it is. Then we have 2n plus 1 cr minus 1. So we add these two, okay. So that we get 2 into n plus 1 cr minus 1. We add the middle terms. Once we have that, we take one of the middle term and add it with this. So we get n plus 2 cr, and we take one of this and add with this. So we get n plus 2 cr minus 1. Then we finally add these two, we get n plus 3 cr. Question 247 says that find r for which 18 cr minus 2 plus 2 into 18 cr minus 1 plus 18 cr is greater than or equal to 20c 13. So we are given this relationship. We split the middle term and add. So as shown in the bracket, when we add, we get 19 cr minus 1 plus 19 cr is equal to 20 cr. So you see, this is 2613 and this is 20 cr. So if you compare with the right hand side, clearly R will lie between 7, 8, 9 till 13. Question 248 says that prove that 4nc2n is to 2ncn is equal to 1 into 3 into 5 into up to 4n minus 1 is to 1 into 3 into 5 and so on 2n minus 1 whole square. So we have this relationship given, we expand it, we get 4n factorial over 2n factorial multiplied by 2n factorial into 2n factorial into n factorial by 2n factorial. So we keep this 2n n factorial and factorial here, and we divide from 2n factorial. So we get 4n into 4n minus 1 into 4n minus 2 up to 2n plus 1 divided by 2n factorial multiplied by 2n factorial. Remember that there are 3 2n factorial in the denominator, only one was cancelled here. Once we have this, you see that if you look at this and you divide by, sorry, you don't divide by, we have this, okay. Now if we take the terms of 2n minus 1, even terms, they will get cancelled by this, and whatever will be the remainder will get cancelled by n factorial, because it is given that we see that 2n factorial is equal to 2n into 2n minus 1 up to n plus 1. Okay, and this 2n will cancel 2 of 4n, and then this 2n minus 1 will cancel 4n minus 2, and 2n minus 2 will cancel 4n minus 4 and so on. So we are finally left with 1 into 3 into 5 up to 4n minus 1 is 2135 into 2n minus 1 whole square. Question 249 says that find the positive integral values of x such that x minus 1 c4 minus x minus 1 c3 minus 5 by 4 x minus 2 into x minus 3 less than 0. So we are given this inequality, we expand the left hand side, we get x minus 2 factorial by x minus 5 factorial multiplied by x minus 1 by 4 factorial minus x minus 1 divided by 3 factorial x minus 4 minus 5 by 2 into 2 factorial x minus 4. So we take 3 factorial common from the denominator, and the terms under brackets will be x minus 4 over 4 minus x1 minus 1 over x minus 4 minus 15 over 2 into x minus 4. So we know that factorials are always positive, hence the expression under bracket must be less than 0. Okay, because x minus 2 factorial and x minus 5 factorial and 3 factorial will be positive. And then we take LCM and take the numerator, we get x minus 1 into x minus 4 minus 4x minus 1 minus 30 less than 0. So x minus 4 greater than 0 implies that x square minus 5x plus 4 minus 4x plus 4 minus 30 less than 0. That is x square minus 9x minus 22 less than 0. Now roots of this equation are minus 2 and 11, but x minus 4 is greater than 0. So x will lie between these two roots, but will also be greater than 4. So x is equal to 5, 6, 7, 8, 9, 10. Question 250 says that 2n pn is equal to 2 to the power n 1, 2, 3, 5 up to 2n minus 1. So very easy question. We cancel out n factorial, and then we have n into n minus 1 into n minus 2 up to 3 to 1. There is something missing here. This should be square. Okay. So 1 n factorial will cancel terms till 1, 2, 3, 4 up to n, and the other n will cancel the even terms. So we will finally have 2 to the power n into 135 into 2n minus 1, which is our right hand side. So how this will work out is the denominator is wrong, it should be square. So if you look at 2n factorial by n factorial into n factorial, then n factorial in the denominator will cancel n factorial in the numerator. So what we will be left with will be 2n into 2n minus 1 into 2n minus 2 through will be left with up to n plus 1. So n will cancel 2n, n minus 1 will cancel 2n minus 2, and it will leave 2. There is it is completely wrong. My mistake, my bad. So what is wrong here is this n factorial is wrong. There won't be two n factorials won't be there. There will be only a single n factorial. Okay, 2n pn is 2n factorial by n factorial. This is formula for Cn, not for Pn. And once we have that, we have this. N will cancel 2n, n minus 4 will cancel 2n minus 2, 3 will cancel 6 and leave 2, 2 will cancel 4 and leave 2, 1 will cancel, leave 2, divide 2 and leave 1. So the odd terms won't cut, but the even terms will all leave a factor of 2. So 2 to the power n into 1 into 3 into 5 through 2n minus 1 will be right hand side. Sorry about my confusion and this typing mistake. So with this, we come to the end of 250 problems. And now I'll show you how you can download my book. So you can go to my website astravoc.org. You can download Algebra, Trigonometry and Conometry from 2nd, 3rd and 4th links respectively. There's a piece of warning though that there could be a lot of typing mistakes, as you have seen, because the book has not been proofread. I have no one to proofread this. I'm trying to fix the problems or typing mistakes as soon as I find them, but still there would be lots of typing mistakes. So with this, we come to the end of this video, and I hope that you are enjoying this series of playlists on algebra, and I thank you for watching the video. We will meet tomorrow with 10 more problems on permutation and combination. Till then, keep practicing and enjoy.